Hello everyone, welcome back to STEM with Chantel.
Well, I'm David Brown Kinloch. I'm the president of Lock 7 Hydro Partners, and we bought the Mother Ann Lee Hydroelectric Station from Kentucky Utilities back in December of 2005, and since then we've put about $3 million into renovating the plant and have it up and running again. This plant was originally built in 1927 and operated by Kentucky Utilities until the 1990s when they retired the plant. This plant is very basic. We have a generator up here, and a shaft goes down through some pillars and down to a turbine that's down in the water. It's about 45 feet below. And so what we have here is a generator, which each of these generators will produce enough electricity for about 600 homes. And this one right here is actually a little bit, we've renovated it, and it'll produce enough electricity for about 700 homes. It's running right now. What we have here in this section is, the basic part of the generator where the electricity is being made in the stator right there, and that is 2,400 volts. It's being produced. We have a thrust bearing in the center, which is holding the whole weight of the shaft and the propeller. And then up in the top here, we have the exciter, which is making the electricity for the rotor, which excites the generator. You'll notice I have to put a plug in here. You'll notice right here it says Center College. Center College has been very instrumental in renovating the plant. They also helped save the plant when it was scheduled to be torn down. And they now buy 40% of the renewable energy credits that come from the plant. So they're an important partner to us. The other interesting thing you'll see here on the generator is you see a kids' art gallery. Back when we were renovating the plant, we took these off and got them sandblasted and primed and took them to my daughter's elementary school, where the fourth graders at Bloom Elementary painted fish from the Kentucky River. So what we've done in here is we've made this a lot more lively in here than the old gray rusty things we found. We've painted the generators Mardi Gras colors. We've got one that's green, one that's gold, and one that's purple, and then made the base of the generators into a kids' art gallery. So it's pretty unutility, but it's a lot of fun. The generator was made in 1927 by General Electric. It was rewound in 1980 by Kentucky Utilities, and it was cleaned up, and extensive work was done on it to get it ready to use again in the mid-2000s when we renovated the plant. So, come along over here, and right here we have the governor. This governor is what opens and closes the turbine gates to let the water in and out of the turbine. It was built in 1927. We rebuilt these in 2007, and these were designed to outlast the concrete in the plant. They do very well. These, when we're starting up, it moves the shaft back and forth, which goes down below, and it moves a ring on the top of the turbine, which opens and closes the gates. What happens is that it will move back and forth to get the turbine and the generator at the exact right speed to synchronize with the grid, so we can come online and start generating electricity. Once it's online, we open it up all the way to make as much electricity as we can out of this generator. Today, this generator right here is producing about 600 kilowatts, or enough electricity for about 600 homes. So what we find here is we have the generator up here, And off of the bottom of the generator is a shaft that goes down. It goes past two large intermediate bearings, which keeps the shaft turning straight, down to the very bottom where the turbine is. The turbine is in the dam, and it's a big propeller, and it's turned on and off by the wicket gates I've described. It's down in the water. Come this way, I'll show you something very interesting. The turbine propeller is kept centered by four of these blocks that are shaped like a cross. Two going this way and two going this way. These original blocks, and this is the original material, is a wood called lignum vitae. It comes from the Caribbean and South America. It's the world's hardest, densest wood. In fact, a set of these blocks costs us $10,000, and it's tripled that price today. But these are water lubricated. Today we've replaced them with a new type of block that's plastic. It's made out of high density polyethylene. And believe it or not, the plastic blocks wear a lot better and don't wear as much, and we can keep them in there a longer time before we have to replace them. They are centered on, the shaft is centered with these by sliding stainless steel plates behind them to shim them to the right position. And as the blocks wear, we add more and more of these stainless steel shims to keep it nice and tight so the turbine propeller stays centered. If we go over this way, I will show you the controls. This is the controls for each of the generators. The yellow generator that I was showing you, here's the controls. Outside, this is a rheostat that we adjust the amount of excitation going into the rotor, which controls the reactive power of the generator. And inside we have a set of industrial control relays, which is basically telling the generator what to do, and the turbine does all the controls. We recently replaced all of these. These were replaced in 1980, and then we've replaced all of these in 2018 to modernize the plant. Another thing we have done is we originally had all these electromechanical protective relays up here. They each say retired on them now. And we replaced them all with this one small unit down here, which is microprocessor based. And it does a much better job, and it doesn't go out of calibration. So it's definitely a great part of modernizing it. One of the beauties of this plant is that we have been able to combine the best of the old, which is this rugged, massive equipment, with the best of the new, which is microprocessor-based controls, stainless steel parts. So we think we've got something better than new, because we've got the best of the old with the best of the new. Over here, we replaced the old electromechanical automatic synchronizer with a new modern microprocessor-based auto synchronizer. And this is what allows us to be able to control the plant remotely, because this and all the controls that we've modernized allow the plant to run by itself, and no one has to be here to run it. We can do it all over the internet, and I'll show you how we do it on the internet. From around the plant, we have all kinds of sensors measuring the temperature, the vibration, all of the voltages and amperages and everything. And they all come into this one central point where we've got them connected. And then actually this one little bitty box over here is the controller. It's the little computer that does all the thinking. And it takes all this information it's getting from around the plant, makes sure everything's running right, makes adjustments to the different equipment to make it run correctly. And then it takes all the information it's gathering there and processing it, pulls it all together, and it goes through a computer, a PC computer down here, and then comes to a screen for us. And this screen shows us all the different things that we were taking, all that information, all the temperatures of all our bearings and generators, all the oxygen information for the river and the temperatures, all the information on our breakers, and then all the information on each of the 3 generators. So it's all in one place. You can go to our website and see that. We put it out for everyone to see how our plant's running all the time. But we also have a specific screen that only the workers can do. We come in and we can start and stop. We have buttons to start and stop and open breakers all on a screen, so we can operate the plant remotely. We don't have to be here to operate it. It's all done over the internet. Again, something they didn't have back in 1927 when the plant was built. So part of the modernization is modernizing the controls so we can operate the plant remotely. When this plant was originally built, they had to have somebody out here operating it all the time. We now have it automated, so it can be operated. It runs itself, it watches itself, and then we can watch it remotely and come in and make changes as needed.
Thank you for tuning in for the STEM with Chantel. Be sure to like this video, subscribe to our channel, and share this video so you can be aware of the next time we upload. Thank you.